Hello friends, in this video I'd like to present my solution to a mathematical problem from Moscow Mathematical Olympiad, 11th grade, second round, 1997. So we wish to evaluate the following integral. Integral from 0 to pi over 2 of cosine squared of cosine of t plus sine squared of sine of t dt. So pause the video if you would like to think about solving this problem. Okay, so my solution, I will make use of a suitable substitution. So first of all, let's call this integral I, okay? And now, let's make the following substitution. Let t be equal pi over 2 minus u, for example. Then dt, so we are integrating, dt equals minus du. What about the bounds of integration? Well, when t was from 0 to pi over 2, now if t equals 0, u equals pi over 2, and if t equals pi over 2, then u equals 0. So the very same integral can be written in the following way. Integral from pi over 2 to 0 of cosine squared of cosine of pi squared over u plus sine squared of sine of pi over 2 minus u, and instead of dt we have minus du. Okay, what now? Now let's see, we have minus here and we have flipped bounds of integration from pi over 2 to 0. We can combine this minus to, we can change the bounds from 0 to pi over 2 of cosine squared, and let's look here, cosine of pi over 2 minus u by pretty well-known formula. It's the same as sine of u. And here we have sine squared, and again sine of pi over 2 minus u is just cosine u du. Okay, and let's also write that this integral was integral from 0 to pi over 2 of cosine squared of cosine of t plus sine squared of sine of t dt. Oh, maybe don't write t, but obviously we can choose any other variable, so let's write u as well. And now let's add these two equations together. So we have 2i equals integral from 0 to pi over 2 of cosine squared of sine u plus sine squared of cosine u plus the lower integral cosine squared of cosine of u plus sine squared of sine of u du. Very well. What now? Now this term and also this term. Look, here we have cosine squared of something and we have sine squared of something. So we can these two terms by another well-known property of trigonometric functions. It's just 1. It's just 1. Maybe it's write it in green, 1. And also these two terms, this and this one, sine squared of something plus cosine squared of something, it's also just 1. du. Very, very well. So we have just two integrals from 0 to pi over 2 du. And now integral from 0 to pi over 2 of 1 is just pi over 2. So it's pi. It's pi. So 2 times I equals pi. So the only conclusion is I equals pi over 2. So our integral from 0 to pi over 2 of cosine squared of cosine of t plus sine squared of sine of t dt must be equal pi over 2. Not very difficult, I believe. So thank you for watching.